performance today. Here's the VG diagram where we labeled these items. You've got the positive ultimate here. You've got your positive limit here in this orange area. Maneuvering speed pointing here. Max positive lift capacity here on this red line. Max negative lift capacity here on this red line right here. Negative ultimate here where the red meets the orange. Negative limit here in the orange. Positive limit here in this orange. We've talked about area of structural damage here, these orange areas. And then areas of structural failure here beyond that orange into the red, and beyond the red here. So, and then limit airspeed is going to be this guy right here. So negative limit's right here, the difference between green and orange, and then positive between green and orange here. So three things that may occur if you exceed that limit airspeed, this limit airspeed here. So exceeding limit airspeed, you can have severe consequences. You can have structural damage because of aerodynamic loads. You can have bending, deformation, catastrophic failure. You can have high-speed flight. Can you have loss of control because of unpredictable handling? And you can also have structural flutter, like uncontrolled vibration. Plane's not built for it. Here's this graph showing the difference between the thrust available for a jet and propeller. Here's thrust on the y-axis, velocity on the x-axis. Jet engines are going to maintain relatively constant power across airspeeds. And it's going to be more efficient for higher speeds and faster climb rates. Propeller-driven aircraft are going to rely on that increasing airflow over the propeller for that thrust. So lower takeoff thrust and longer takeoff distances. When flying a jet engine, changes in weight and altitude are going to shift that thrust required curve pretty predictably. If it becomes heavier, the curve is going to move upwards and to the right. If it needs more thrust to maintain level flight. If it becomes lighter, that curve shifts downwards to the left. At higher altitudes, where air density decreases, the curve moves upwards to the right as well, demanding more thrust. At lower altitudes, it's going to be higher air density, it's going to shift downwards to the left, just like we talked about. These are going to be affected by gravitational forces. How does it change during flight, cruise versus straight and level flight? So during turning flight, power required typically shifts upwards to the right because you require more power due to the increased lift requirements, counteract centrifugal forces. Also, that induced drag as one wing rises creates that drag as well. Turning involves higher air speeds and drag. The aircraft's angle of attack and banking also. It's going to also affect that as well too.